try to see if I can record it. All right, so our main agenda is to review basic SQL in 40 minutes or 50 minutes or so. That should not be very easy. And I have all the homework questions. If you want me to solve any one of them, I'm happy to do that. And then we can look at different ways to solving them. In the past, when I solved homework questions, people were extremely bored. So it's up to you to request certain ones. But let's remember the basic SQL, and then all the bells and whistles that go with that. So the basic SQL syntax basically revolves around select from where. Of these, one of them is optional. Which one is optional? Where. Good. So optionally, you can add a group by. And optionally, you can add a having. Right? But if you have a having, you have to have group by, obviously. Right? These are all optional. And then you can add as many of these as possible and then combine them with set operations. Other select from where. As well as group by having, if you want. This stuff is now old news for you, but I'm putting it anyway. And then you have, set operations here. You can have union, union all, intersect, except all, and so on, right? Then you can have as many of these as possible. You can have other select from where and so on. This can go for a long time. Then you have an order by, a single order by, and then a single limit if you want to have a limit. It is important because since the order by comes last, right? If you have a union query, after the union, you don't have b.name, you only have name, right? So have you tried to have a query where you have same attributes, but they are called different things, and which one is the one that it counts? But generally, whatever you have, let's say b.name, right? After the union, you actually have to order by name because this context of relation B is lost after you do the union. Okay? So we said that all of this is executed in a very specific order, which matters. That you go from to where to group by to having, back to select. Same as true for this one. And then these two selects go to union. And then you go to order by and then to limit. So the ordering is important because in group by you cannot refer to an attribute in the select. You can only refer to something that is in the from where, that's above. Now it is possible that in this massive thing, you can also have subqueries. So you can have subqueries in many different places. You can have subqueries in select. But if you have a subquery in select, it has to be a subquery that returns a single value, right? Because otherwise you cannot select uniquely. So we had a name for a query that returns a single value. We called it a scalar query, right? So it should be a scalar subquery. You can have subqueries in from, but those queries have to be completely standalone, meaning that they cannot refer to any relation outside of that. So if you have a subquery inside of from, it basically is like saying execute this query first, give it a name, and then use the output in the rest, as if it was a table. We call these anonymous views. So here you can have a query, and I'm going to say is a standalone. That doesn't refer to anything outside of the query itself, right? Doesn't really join with anything outside of the from of itself. You can have a subquery in the where. If you have a subquery in the where, depending on what your connection is, you can have one that returns a set or that returns a single value, right? So if it's a single value, you can search that it is 0 equals to the subquery, like the count. Or if it is so this could be a scalar subquery. Or you can have something that selects, for example, one is in this, something like that, right? If your query returns a set of things, then you have a certain thing you can ask. I will talk about that in a second. And then you can also have a subquery in the having, and the rules are the same. So group where and having, you basically have the same kind of subquery. Depending on what it returns, your conditions will differ. All of this, with all the subqueries attached to it, is still considered a single query, right? It is not considered more than one query, however massive it is. Any questions so far? Okay. So, remember the basic types of subqueries. So maybe I'll try to use a, okay. So subqueries. So we said that a scalar subquery is one that returns a single value. And this is how you do comments in SQL. Okay, so something like select count star from students. All right. So if you have a scalar subquery, for example, you can return that in select. So you can select name and select count star from, let's say. So let's say I have students S. Okay. So this is a subquery that returns a single number. You would treat it as if it was a single number. Doesn't mean that you should really do it like this, because this is not actually necessarily an efficient query. The database may not be able to understand that you can also do this with this very simple join. This is the same exact result, but there are sometimes where you're counting two different things, and if you write a query to count one, you cannot count the second one. In that case, you put a subquery. But there's a point beyond which your query is way too complex, then you probably should write a procedure and store the results in something and then reuse them, because breaking it apart is going to speed it up. So the other subquery was, so you can also use scalar subqueries in where or having. So, you can say something like, so you want to basically return all students such that, let's write this here, such that the number of classes that they are taking is at least 5. All right? Or you can have the same thing in having. So you can say, okay, return all students such that the number of students, the number of classes that they are taking is greater than the number of classes some other student taking, right? So anytime you have a scalar subquery, you can treat it as if it was a single number. But if you have queries that return a set of results, so we will call that general subqueries, you can use them in many different places. So you can, for example, have a query, let's say, of all students who are currently taking a class. So, you know, select So these are all students who are taking at least one class, right? And then let's call this S with class, okay? And then I can take this as if it was a real table, join with another table. Now the only rule is that this query here cannot refer to like a transcript key. It has to be standalone. It cannot really refer to something outside. So that's the most important rule. So, so we will call this, so SVC in this case is an anonymous view. I mean, it's a real view. A view is just a query, just doesn't have a real name. So you can also use queries in where statement. Now, if you're using a query that returns a set of tuples, then you have to compare a value to a set. So to compare a value to a set, you would have value, and what do we have? We have in, not in, greater than or equal to all, greater than or equal to any, etc. Okay? So this is one way to compare. The other way to compare is just simply not exists. Okay? Or you can also do exist query. Okay, so you would have something like something like that. This is a set, and you are checking for a condition that has an in, not in, exist, not exist, or something like that. You could probably write the same thing without not in and say not exists. If you're doing not exist, now you have to have a condition that really relates to that tuple. Because if you write it like this query simply says return a student if there does not exist any tuple in here. So this will return what? This will either return all students if there's nobody in the database who got an F, or it will return no students if somebody got an F, because it really has nothing to do with the student S. If you wanted to then correlate it with the student, you would actually have something like where grade is F and t.studentID is equal to s.id. Okay? So now you're saying return the student if for this student there does not exist a tuple in transcript with grade F. Since now you are not actually checking the values of this attribute, it really doesn't matter what you return. So you can change that as you wish. Now there's two different queries that are basically exactly the same, right? But there's a big difference between the top one, which this one is we call uncorrelated query. The uncorrelated query basically has this inside query, the nested query, that you can execute once and then look up every time you execute the outer query. Whereas the bottom query is correlated. Right? Which basically tells me that for each student, execute this separately. So depending on your database, this one may be much more efficient than this one. Uncorrelated is generally better, but better databases are able to optimize for both, but there is no guarantee. Whatever you can do in the where statement, you can also do in group by. So I can say something like, for example, I can say that select all students such that the number of classes that they have taken is greater than or equal to all in transcript T That's it. Okay. So now this one is telling me that return a student if number of courses they took is greater than or equal to all the counts for each of the students, right? So this one is looking at transcript, grouping by the student ID, and returning count. So it's going to return counts for one count for each student, right? And then I want to return this student if the count for this student is greater than or equal to all. So this would be what? I'm returning a student who has maximum number of tuples in transcript, right? So students with maximum number of tuples in transcript. Now, this is very similar to one of the queries that you had in homework 4. And somebody asked me this question. Instead of doing it like this, can I do it like this? So instead of this, I am going to give this a name, num courses. I'm going to order by num courses descending, and I'm going to limit 1. Are these two the same? In one, you're finding the students with the max. In the other one, you're finding the students with the max. Are they the same? You have to get your brain engaged. The same thing that I have to do when I read your queries. That's right. It really does, like you really feel like there are parts of your brain you haven't used in a long time when you're reading exams and so on. It's like, oh man, there's all sorts of neurons are excited. Okay, so this is not the same as that one. Because if there are multiple students with the maximum number of classes, this will return all of them, right? So if there are 3 students who took 25 courses, I will return 3 students. In the second one, I will only return 1 student, right? Here, no matter what you do, this returns only 1 student. Yes?
In that having statement, where it says greater than or equal to all, is that meaning that it's going to compare the count to every line, every row? Okay.
So like, let's see what happens when you run that one. All right, so let's say, right, it really doesn't like it when I cut and paste, but yeah. So it will basically give you counts, right? It will just, every line is a count, and you're saying that the count for the student is greater than or equal to all of them. So basically all you're saying is that the count is equal to 6, right? If you actually set strictly greater than, you will get nothing, right? Yeah. So for this query, it will be the same because there's a single student, but if there were 2 students, then I would have 2 in the other one. Okay? So, basically, this is what we did with subqueries. Subqueries are important because they give you power that you don't have, and there are specific cases where you absolutely need them, but not always. So always ask yourself whether can I do this differently. In the exam, you write whatever query that comes naturally to you. As long as it's correct, you will accept it. All I ask is you indent it. Don't make a continuous line like goes like this. Okay, just indentation. Select from where, space for the next line. So, but in real life, using in is not necessary. Often that if you write it with in, it is converted to a join. But joins are generally easier to optimize unless you're joining 10 tables, right? Which sometimes does happen. So if you're not joining too many tables, join is better than subquery. Uncorrelated is better than correlated. Remember that almost always, if you have an in query, it's a positive one. You don't need it. You probably can write it with a join. So, so generally, avoid in, use joins instead. Now for not exists, not in, often you can use that. You can write the same thing, except. And set operations are turns out are more efficiently implemented than subqueries, because subqueries is like for each query you have to check something, whereas set expressions are actually easier to optimize. But very often you will find the query plans are very similar, and when we do that after exam, you will see. Okay, so so set operations are important, and if you can, avoid correlated subqueries if you can. But we did one where you basically couldn't avoid it, but there were ways to get around it. One thing that we did do was talk about left join. Left join and right join are the same, except you just flip the relations, but the full join is slightly different, right? So the left join and right join or full join, the power they give you is basically they allow you to do a join without eliminating one of the tuples from one of the relations. And if you learn to use left joins well, that they can help you solve some things, and they tend to be efficient depending on the system you can test. Okay, so it's not like, I'm not telling you they will always be better, because somebody was telling me that I love left joins too much. I just happen to like it because it gives you the different way to solve the same problem, right? Something that would have been difficult or needed a subquery, you can do with a left join. So if I were to do something like this, so these are called outer joins. People just underuse outer joins, that's all I'm trying to say. But if you're using an outer join, you have to do your join in the from statement. So for example, from students S, left join transcript T. Now you have to write the join condition right here. Okay. Now the idea is that in this case, students, for each student you will have a transcript tuple, except if there is no tuple for that student, then any attribute from transcript is going to be empty or null, right? So those tuples will have no value. So for example, you could just say t.studentID is null. It kind of sounds illogical because you just joined on the student ID. How can it be null, right? But these are the tuples from students that don't have. Okay, so these are all students who have no classes because when you join that, there is no tuples for them. Okay, so it's kind of a boring example. Now the thing is that let's say you want to find students who have not completed a class, so they may be registered for some classes, but they have not completed the class. If you want to say something like t.grade is null here, okay, so don't forget null when you are searching for null values. This will not work because you already joined. And if you wanted to find students when they join with the subset of transcript tuples for which the grade is not null, that this is not the way to find it, right? So if you wanted to find students who have not completed a class, okay, or registered for one, this will not work. So what you need to do is you need to put your statement here on s.id and t.grade is not null. Okay. So this basically has student tuples joined with transcript, but only those tuples of transcript where the grade is not null. If there is no tuple from here that joins with that, then it should have null values, right? So let's try to see if this will work. Okay. So basically, these are all the students, except these students have nothing. So let's try instead of this. Okay, so this has 14 rows. This has 11 rows. So that's a different thing. Because what happened in this case is that I found for each student, if they join at all with a tuple from transcript, if the grade is not null, that means I've eliminated anything from student that did not join, which is not at all what I was looking for. So what I was looking for was this. Find students who have not completed anything. So one thing that we have learned that you can also look for is if you were to count the number of tuples, that will basically count number of tuples, right? If you count a certain attribute, it will count the number of grades. So this is actually does not really mean anything in this case. So anytime you do count by an attribute, if it's a null value, it counts as 0. Okay? So even though there is one tuple for this student, it actually has no grade. So these are all zeros, and for these, each of them actually have courses, so it is 5 and 3 and 3. So when you're counting, it's important to know whether to count star, number of tuples, or count the values. So if there's going to be null values. One thing we talked about was that if you're going to return ID and name, technically you have to group by ID and name. In fact, that remained true in 15 years that I taught this class. But recently, Postgres implemented, bless you, the constraint checking so that given an ID, since ID is primary key, name is unique, it doesn't give you an error because it knows that if you have group by ID, you can return the name. So if you're using Postgres, a newer version, you can actually just group by ID and group ID and name. But if you're using another database or an older version, that may not work because they have just chosen not to yet implement that. Okay? So by general principle, I try to group by everything that I'm going to return. This helps me kind of be present in my query writing. So left join is cool because you can do all sorts of things. For example, we were saying things like, so if I take this query, so for example, you can say that, return all students such that the number of courses that they have completed is equal to something, right? You can write a query right here. I think that I had a much more complex query, but I don't know if I want to go into it right now. So you can say the number of courses is greater than or equal to select select count star from greater than or equal to all from transcript where this is not great in the sense that this is not a great example of left join, but anywho, you can see that you can put nesting. But remember that in the exam, I'm much more likely to ask you non-nested queries. So nested queries, as soon as you learn them, you become kind of it becomes easier to write nested queries than not nested queries. But often I will ask you lots and lots of joins. So in the most, you will maybe have one query that may be useful, easier to write with nesting, or maybe two, but no more than that. So I just want you to kind of see all these different ways to write nesting, but remember that you understand how to write the basic select from where. The other thing that we did after this, so let's see, anything else from regular select that I forgot? Select from where. And remember that if you have different selects, you have basically two versions of the same operation. So you have set operations and you have bag operations. Okay. So set operations will basically return you a set even if the inputs are not unique, right? So even if you have two queries, they don't have distinct, when you do union, it will actually remove all duplicates and return you the unique tuples. So this is union, intersect, and except. And the bag operations are basically union all, intersect all, and except all. And I always ask you, as a, it builds character, that you can remove duplicates by using distinct, but make a habit of only using distinct when you really have to. Okay. Now, on top of these, we basically learned a bunch of other operations that build on those. Things like insert into table, where you can have values or insert into table, where you have a select from where query. In either case, you have to basically have the same attributes in the table, defined in the order that they are defined. If you wanted to change that, you have to write the attributes, right? So you have to write, attribute 1, attribute 2. Then you can have a query that basically has two attributes. Whatever you don't write in the table, so any attributes you exclude are expected to be null values. So if those attributes cannot be null, then this query will fail. It will insert nothing. The second one we learned was update table set attribute 1 to some value 1, attribute 2 to some value 2, where filter for tuples, right? So for example, you can say update students set GPA is equal to 0.0, where these are the new students. So now you have to say where there are no tuples, there are no transcript tuples for these students, but you cannot have a from statement here, right? So generally, now you know that you actually go to a different table. The instinct for every student that I've seen is to write student's transcript, okay? This does not work because which one are you updating? Are you updating students or transcript? You can only update one table at a time. So you can only update one table. If your condition refers to another table, you can say where not exists. This is where nesting is necessary. Select one from transcript where, and let's call this T. Again, when I first was doing this a few years ago, it was not even allowed for me to, put an alias here like students S. But now Postgres allows it. Thank you for that. But I'm not going to use it just because now I've learned it the hard way. T.studentID and T.grade is not null. Something like that, right? So this is telling me update students for whom there is no transcript tuple without the grade, and set their GPA to null, right? So if you did not have a where statement, it will set every single student, and there is no undo for that. So, be very careful when you do insert update. I'm so careful that I always insert it to a different table just in case, right? Because there is no way to really recover from this. The other one we learned was delete. That's even worse. So delete from students where some filter for tuples. If you don't have a where statement, it's going to delete all the students. If not, you're going to basically have a statement. So delete from students where, let's say, where year is equal to 2016. Graduated, out of here, all right? If you wanted to have a more complex condition, you have to use a sub-expression. You have to say where where I'm going to delete all students who have not taken a class in the last year, right? So where T dot semester is equal to C dot semester. Oh, I guess I don't need this because this is already here. Where student ID is equal to students dot ID and T dot year is equal to 2016. Something like this. So the number of classes that they have taken in 2016 is 0, then I'm going to delete them. Maybe it's better you insert them in another table and so on, but regardless. or you want to generate, email. Or anyway, so we have seen insert, update, delete, and then we have seen that if you're writing a procedural code, you basically have to piece them all together. At which point it's important to kind of remember transactions. The most important thing we have to remember about transaction is this feature that we call atomicity, okay, which means all or nothing. So if you have operations that change multiple things, all of them operate in a single transaction block. If this triggers a different thing like a transaction, a trigger, the trigger that it triggers becomes part of the same transaction. If any of them poses an error, then the whole transaction fails. As a result, nothing is inserted, nothing is deleted. So you can set the bounds of your transaction with begin and end, and make sure that that will make sure that everything in that block is either done all at once or nothing is done at all. Yes.
Is there a efficient way to create a table with the copy of a schema of another table without copying over all the tuples?
I think it's called create table. There's a way. There's a way, but you have to look up Postgres.
Okay.
I know, but you can actually have a query that returns nothing.
Okay.
So, let's say, okay. So first I will show you the duct tape version, but I'm sure there's a way. So you can say create table XYZ as select star from students where false. I am known for my laziness, but I am sure that there's a way you can do that. So one thing that you should also watch out for is that when you're writing the procedure for the homework 5, it is transactional, but it's sometimes weird. Okay, so I don't always understand the transactional bounds, but if you have a transaction, this is the same thing why my drop didn't work. Like let's say if you have drop, and create, right? So, but first drop actually fails because you actually don't have the tables right now, right? So what will happen is that since that one failed, it will not do everything. So everything after that will fail. But sometimes what happens is that it still outputs something in between before it fails. Like somehow the breaks doesn't come very fast. So I'm not read up on everything. So it's kind of, you're not exactly sure what happened. That's why I tell you not to use temporary tables because they're kind of confusing. But remember that your procedure, your function executes transactionally, right? So that means if somewhere in there something goes wrong, you may see none of your tables are populated at all, even though it printed out that it actually did something. So because of that, it's important that you test your queries separately before you shove them all in a single function. That's all I'm saying. It's kind of weird. I was not always sure what was going on. Okay, so that was about transactions. We basically talked about whenever you do insert, update, delete, basically anything that touches a table and changes a table, it also checks all the constraints in the table, whether they are violated or not, after the change, right? So after I insert, do I violate transaction? Do I violate constraints? And if I do violate, even though you may be violating only for one tuple, all the tuples you are going to insert will be aborted. Okay, and as a result, you have to worry about basically what the transactional bounds are. And if you have begin and end, generally this is considered a single transaction. So all or nothing. So we learned about different constraints, things like foreign key, not null, check constraints, primary key constraints, unique constraints. Okay? These are all checked, and if there's a violation, there's generally the default action is that your whole transaction is aborted, except for when you have explicit statements. Like, for example, we know that for foreign keys, you can have fixed functions. So you can have, for foreign key, things like on delete, update, or set null. And on update, cascade, and set null. Okay? So if you do have these, then basically, even if there's a violation, if there's an action, and that action can be carried out correctly, then you may basically not have to abort the transaction, and any of the changes that are executed as a result of this is part of the same transaction. And the last thing we learned was triggers. So the triggers basically also become part of the same transaction. And I recommend that you go and check the trigger syntax and how it works, because this is one of the things that I like to ask, so you can see that. Okay, so this is my quick overview. Do you have anything that I didn't discuss that you want me to quickly go over? Yes?
Sorry, maybe I just missed it. What's a trigger?
Triggers, we covered them in class.
Was it on Monday?
Probably.
All right,
So basically the point of a trigger is that it's a procedure that fixes things for you, but you have to describe when the trigger should be executed. So it's an action in the database after, before, or instead of an update, insert, delete of a table. So you say, if you're inserting this table, look at this trigger. And the trigger should be executed if a condition is true, that's a when statement. If the trigger is executed, then there's a body that tells you what to do, right? So either all of that has to succeed or the trigger fails. Now, the point of triggers is that they can trigger others, and all of that is part of the same transaction. And if you don't write it correctly, then they may never end, which is perfectly a valid possibility. And then you have to be careful about the before and after syntax. So a before trigger is basically accessing the tuple that you're going to insert or update or delete before you insert or update or delete. So if you were to change that tuple, then the updated change tuple is inserted or deleted. Okay? The deletion doesn't make as much sense, but insert and update does make. So the before trigger accesses the tuple in that gray zone before it was actually inserted or updated. The after trigger sees the table after you inserted or updated the table. So even if you were to change the tuple, it has no effect. So generally you use the after trigger to fix something bad that it may have caused, or update the number somewhere else you're storing. So you can have triggers for each row or for each statement. I generally never wrote for each statement trigger, so you always see a for each row trigger, because that's what I know. But it is equally valid, so review the syntax. I have it on course notes, okay? And it basically builds up on the PLPG SQL syntax. But if I were to ask you to write a procedure, it will most likely not be a trigger, but you may get a trigger and you have to see what it does. You will see examples in my past exams. Anything else? Yes?
How many total questions?
I have no idea.
But it's going to be regarding all the SQL.
You can see all my prior exams. It will be exactly like that. Yes? Inner joints, of course. Well, I mean, the point is that you never need to write inner joint because everything you do is an inner joint, right? But you can write it as inner joint if you really want to, and that's easier for you. Technically, there is no difference because the database will rewrite it as the same thing. Yes?
Will you post this on the notes?
Yes, I will post this on notes. Everything that I've done, all of the stuff that I write, I've been posting under Piazza if you've never seen them, and the course and the lectures also. Anything else? All right. Good luck studying. I will see you on Thursday.